Hey everybody, Norm from Tested here, and longtime followers of VR and PC VR enthusiasts specifically will know what this is. This is the Bigscreen Beyond. It's a VR headset launched a couple years ago now that's still one of the most unique designs for VR headsets out there in the market. The folks behind Bigscreen, the software platform, decided to make a headset that was ultra light with a high resolution panel that was also custom fit for your face, a very boutique-like product. Well, just this past week, they announced the Bigscreen Beyond 2, its successor. And on its face, it looks a lot like the Bigscreen Beyond 1. In fact, they share not only the similar design aesthetics, but also the same actual 2560 by 2560 per eye micro OLED panels as well. But there are a lot of subtle and important differences, not just the different faceplate colors that you can get. The optical stack is completely different. They've managed to improve the optics, to improve the field of view, this all-important attribute of VR headsets. Now they have a 116-degree diagonal field of view, improved from, I believe, 102 degrees in the original, as well as decrease optical artifacts. One of the things I noticed most when reviewing the Bigscreen Beyond was in dark environments with a bright screen in the center, like a cinematic environment for watching movies, I would get glare. Bigscreen Beyond 2 aims to decrease that glare, improve the edge-to-edge clarity, as well as still increasing the field of view with those same display panels. They also have a now adjustable IPD. One of the issues that users had with the first version was that not only did you have to send your own face scan in for them to make this custom fit cushion, but it was locked to your IPD. It wasn't user adjustable after the fact. So it made it difficult to share these between users, as well as maybe sell the headset if you wanted to upgrade to something else. Bigscreen Beyond 2 has adjustable IPD. You can use a small tool on either side, on the hole on either side, and you can actually tune and move the lenses and the panels and slide them as they would have done in the factory beforehand. I think that's a massive improvement. So I was able to try Bigscreen Beyond 2 and compare it with Bigscreen Beyond 1 for a few minutes today in a hands-on demo. And the first thing I noticed was that increased field of view. Sitting in a cinema environment and loading up YouTube on the big screen, I was actually able to move one row further up and still have the screen comfortably fill up my field of view without having to shift my head left or right. That was something that was different. The other big difference was that optical clarity. The glare is now gone. I loaded up a bunch of different environments, really dark environments with a bright screen in the center, and loaded up some videos, and the glare was not only better than what it was in the Bigscreen 1, but I think even better than what I'm used to in the Apple Vision Pro. More testing is, of course, needed. I also got a chance to sit down with Bigscreen CEO Darshan Shankar, invited him over to the studio to have a long conversation about all the engineering decisions and design decisions that went into Bigscreen Beyond 2, how they improved that optical stack, what were the new manufacturing technologies that allowed them to do so, why they kept the same display panels, and how they think about a universal fit light seal, which is something they're going to be selling later this year, versus a custom fit cushion for their headsets going forward. Let's take a listen. You said it's been about 2 years?
2 years.
I can't believe that. It felt like just last year that you were here. It's been 2 years since you were last year showing off prototypes for Bigscreen Beyond the first.
Yep.
And what a surprise that you just this week announced Bigscreen Beyond 2.
Yep.
So you have some samples, we're gonna get some demos, but I wanted to use this opportunity to pick your brain about how you guys think about developing this follow-up, the Bigscreen Beyond 2E that you also announced with eye tracking as well. But maybe first a little recap. It's been 2 years since you guys announced Bigscreen Beyond. You guys have been shipping for over almost a year and a half now, a little bit. What have been the lessons learned, the feedback that you've heard from your consumers?
A lot. So Bigscreen Beyond 1, we knew from the start it wasn't meant for everyone. I think that's actually in our trailer. It's one of the first words. This is not for everyone. But we wanted to take a bold stab at what VR could be, particularly for the enthusiast. So we care a lot about visual fidelity and comfort and ergonomics. So our core design philosophy, every gram matters. When we put
Right.
out Beyond 1, it was 127 grams. That was like 4 or 5 times lighter than most headsets out there. I think if I recall correctly, it's like 6 times lighter than the Index or other much larger headsets. We really want to plant a flag and say VR should be ultra light and ultra high resolution. And we did that with our first generation Pancake optics, with ultra high resolution, 1-inch micro OLED displays. We really took a bold stab with that, but we did one other thing, which is custom fit. So we had 18 different sizes of IPD, the distance between your eyes, and we had the custom fit cushion.
This is so cool. A face scan, something perfectly fit for everyone's face. And I mean, that makes this boutique thing that's made for you.
Right.
Also made it kind of tough for other people to try it.
Sure.
And made for tough for people to maybe, if they didn't get the scan perfect, or limit the range of the IPD. There are going to be outliers for some type of people.
Yep. We learned a lot with that.
That feedback seemed to be what generated the direction for Beyond 2.
In some part. So one thing that we learned was about 16% of people on average ended up needing to have some adjustments made to their device, like a slightly different cushion with like, hey, there's a little too much pressure on my eyebrows, or there's too much cheek pressure, or something like that. Little tweaks to a custom cushion. And now this cushion is truly made to the shape of your face. So we need an iPhone face scan, which immediately meant that Android users had a hard time even buying the product. It was required, right? So number one, we were closing the door on a large number of customers just by making it really hard to even get in the experience. Second, some people had an adjustment. Custom fit worked, but with like an asterisk, right? It worked, but not for everybody. And we also left out quite a lot of customers, particularly business customers who wanted to use it with potentially 100 people in a single day. So that's why we took some of those lessons, applied it to our thinking for Beyond 2 to keep what was working, and then also do a few other things.
Yeah, we'll talk about that Halo strap that you guys have coming up. Also, since the last time you were here, Apple launched Vision Pro. Vision Pro has come out. It's been out for over a year now, and I think it seems like it validated a lot of your design decisions in that they prove high resolution panel. What is its biggest selling point, right? People are loving. I love watching media in it, watching movies, and that's like the core of big screen's business, right? A big screen. Also, them using not as custom, but still fitted and with an iPhone scan, facial interface also validated that. But they went heavy, and you guys went light, which also I think validates some of the decisions in their approach. Yeah,
I found that to be genuinely validating. As a product developer, as a designer, we were right about so many things. And it's cool to think that, because Apple's got brilliant people there who also do their design work and research and so on. We came to very similar conclusions that perhaps VR should be, custom fitted to some extent, and it should have micro OLED displays and even 3D movies in VR are particularly compelling. Something that you and I would have talked about, 8 years ago with our Bigscreen software first launching. It's validating for sure.
So of all the things that you guys could have iterated on, there are higher density panels. There are, there's certainly new optics which you guys have. There's inside out tracking. There's, maybe separating yourself from Steam VR. What got you to changing fundamentally the optics, and then also IPD makes sense as an adjustable thing, but optics as the thing you guys really stepped up on?
I'll start over this way, which is for people who bought a Beyond 1, write down your list of things that you would love to see in your Beyond 2. Great, let's just go do that. Right? So we talk a lot to our customers in our community. We spend a lot of time in Discord, like hanging out with people, using the device. And we learned, well, here are the things that people wanted. What's your wish list? Great, let's just go do that. And that explains all the different features we added in here. That being said, though, some of the research and development for this, as we've been doing research and development on optics and tracking and computer vision and cameras since 2020. So that just comes out when it's ready, right? There's a lot of things that we're doing today that did not exist or wasn't ready in 2023 or 2021. So a lot of that is just, we're going to be constantly working on this. Beyond 2 succeeded well enough to allow us to innovate and ship what's now Beyond 2. Beyond 2, already out of the gate, has succeeded well enough that I can promise you there will one day, years down the road, be a Beyond 3, and then there's going to be Beyond 4.
Amazing.
It's working.
Well, I think keeping the form factor, you guys are keeping the same panels, right? The same display panels means that you can focus, right? You guys are still relatively small team. Optics, even as I recall, going from the prototypes you had of Beyond 1 to shipping, you guys changed the optics for slightly different.
There was a
field of view.
tweak.
The
There was a
right.
thing that we learned along the way in terms of adjusting optical design that we slipped in
Yeah.
a few months after launch because we didn't want to save it for a future generation when we could improve the current, at the time, Beyond 1 generation.
Oh, it's interesting. I'm looking, this is my first time seeing Beyond 2, and I thought you had a prescription cover on here because it looks different. It looks like the surface area, is it smaller even?
Yes.
Than on Beyond 1.
So this
which
is
made
where
me think there was a prescription cover on it, but there isn't.
it's so funny. For the past year or so, the number of people online or Beyond 1 customers like, man, I wish, the next time they do something, they should just make the optics a little bit bigger. And even if it adds 50 grams of weight, that'd be okay.
Right,
if only they could. And, last year I started giggling.
Right.
Quietly to
Let's
myself
talk about that. I think let's educate people about what it is, because you think of it obviously as a stack. The optics are in relation to the panel. So keeping the panel fixed means that you know your form factor, but how do you think of the stack? What is changed in this stack that allows for the benefits of increased field of view and reduced glare and clarity edge to edge? Those are your big three things.
Yeah, there's so much to talk about. We can talk about displays in a little bit, and 4K versus these displays. But when it comes to optics, it's really, really interesting because it's the full. It's all of the components combined. It's not any one single component. One of the really funny things that people might say is like, there's lens glare in some pancake optics. Yeah. Actually, in all of them, there's some glare.
Yep.
Why don't we try anti-glare coating? So I'm like, that's not how it works at all.
Right.
It's the full thing. Everything affects each other, from design and simulation, right? Like how the architecture that you could take. But that has to be reinforced by what can be manufacturable in the end.
Sure.
Right? Because you can create wonderful architectures that will never be manufacturable. Or you could only make one of them. You can't make it at scale. So then we do some prototyping. We'll do diamond turned optics, like make just a couple of them. Each lens would be tens of thousands of dollars, but it'll understand our design principles fundamentally in the right ballpark. But then there's films and material selection. Okay. What type of plastic or glass, and refractive indexes, and the materials that go on top of that. Right. The polarizers and the various films that are used to create the pancake optic architecture, the half mirror, the quarter wave plate, and so on.
Is it that you've had more time to run now your simulation so you can try more, and that you found the right combination of those things? Or is it that some things have gotten cheaper or more available?
Nothing's gotten cheaper, unfortunately. But in part because we're always trying to use the bleeding edge. We're always trying to use what just came out or is about to come out, and trying to sneak that in, because we're not trying to make 20 million of these the way Quest has sold. MetaQuest has tens of millions of units sold. They're playing a whole different game. Our game is to always get the absolute cutting edge and sneak it in to get this as good as possible today, right? Our opportunity is, how do we bring to you, Meta might put out a device like this in 5 or 8 years. But what if you could have something like that today with completely different constraints?
So it's contact with your suppliers and their yields, what they're able to deliver, matching that with your anticipated audience base.
And suppliers in all parts, from the design stage that we do. So these are custom optics that we've made, but we don't just do this on our own, right? There's so many people that we work with to pull this off, from lens suppliers to material manufacturers to the assembly of these as well, because assembly is critical. Alignment, down to the subtle tolerances are quite difficult.
Maybe answer a question for me. So that's something I've been really curious about when we saw the Vision Pro, and they haven't really talked about their optics, but theirs are concave, right? And you guys have, I understand, like flat optics. I think the Quest 3 kind of are more they're convex, or the other way around, right? But like, what are the differences? Are those just like the ways you run the simulations, or just fundamental difference in approach and design?
So pancake optics in general is light goes from the display, bounces off a surface, goes back here, bounces to your eyes. Yeah. And where do the bounces occur, and how many lenses do you have, and what's the shape of each of these surfaces? How many total surfaces? They all affect your lens design. And each of these has trade-offs. Trade-offs in cost, trade-off in manufacturing complexity, the shape of surfaces, the complexity of that affects whether or not you can put films on them. If it's a really complex surface, maybe you could put films on them, but you might have a lot of distortion, or you might have a lot of yield problems because it's just too complex of a surface. But also, machines are getting better and better. So the machines we have today that can handle far more complex surfaces and geometry, for the interior of the design. So it's not something you might even be seeing on the outside. I'm talking about things that are on the inside.
Yeah, within the stack.
Within the stack. These machines didn't even exist 2 years ago, or you know, they might have existed in more of the proposal stage, or you know, we're discussing the availability of it, but it was a theoretical promise. And now these are actually ready and available for us to utilize. So that's why I say it's kind of the full picture. We can design something, but it has to be designed kind of in concert with what's currently or what's about to be able to be manufacturable. That also affects your material choice, but also where those materials go. It's the full picture.
What I'm hearing is that it's one, not a solved problem, and two, that the continuous improvement means that you have a roadmap for improvement as new manufacturing processes get mature.
Exactly.
As you guys can run more simulations, and so that all is
exciting
all things to look forward to.
It goes hand in hand, and it's something that's continuously growing. And I think one of our biggest strengths is that we've now been doing development in pancake optics for 5 years. So we're getting better and better and better at it. And I'm really proud of this because I think our first generation device, I think we proved Bigscreen can make hardware. With our second generation device, I really want to prove to the world that we make the best VR pancake optics. And I'm hoping the world will see that when we start shipping.
Well, let's talk about panel then, right? You know, I think when we first talked about Bigscreen Beyond 1, you guys were seeking out the smallest, highest density. You know, those things gave you lightweight, but also that fidelity. Again, Vision Pro coming out. Have you seen a change in, you know, supplier side interests, in manufacturing capability, and all those benefits of new players entering the market in that space and giving you more options to think about how you can choose a panel?
In some part, yes, because we're a small company. Well, we're getting bigger and bigger by the day, particularly with the second generation. We don't have the weight and push in the industry the way Meta and Apple do. I mean, they're the largest in the world. Suppliers, particularly display suppliers, invest enormous amounts of capital in the hopes of getting the Meta and Apple contracts at some point down the road, right? They're patient. They're playing a 10, 20-year game. They're trying to win the industry, not tomorrow. But they're also looking for more than just one customer. They don't want to only be reliant on Apple revenue for their display business to succeed. That's dangerous for everybody involved, frankly. So they love working with companies like us that have proven enough to know that they have the volume, they have the consistency of shipping, that they're a real manufacturer in the space and not a startup with an idea. So yes, our relationships with manufacturers and display vendors and the whole supply chain has really dramatically improved once people realized this wasn't just a cool concept shown at CES. This is a real thing that people love. So it's improved. But
how do you think about, I guess, a 4K panel, right? This is a simple way to ask that question. You know, how do you think about
that is the best
anything
question.
Higher than 2560 by 2560? Is it also looking at performance of GPUs and what people are running with that, frame rates, like finding a sweet spot there?
I have strong opinions, and I really wish people better understood this. We get a lot of, I wouldn't say pressure, but a lot of like encouragement from suppliers who are saying like, hey, we're making these things, they're 4K micro OLED, and we've seen all of them. We've had them in-house since 2023. We've tried all of them, we have them, but why wasn't there 4K micro OLED in Beyond? I think that's a fascinating subject entirely for its own. And it comes down to, and frankly, even consumers are asking that all the time. Oh, the next gen, I bet it'll have 4K micro OLED.
Sure. It's an easy spec to say move up to. In their minds, sure.
It's just not. And it comes down to a few key concepts. First of all, 4K micro OLED, with the exception of Apple's panels, haven't really had great yield yet in manufacturing. So they're really early. There is no, except for Apple, which is a custom display, different size, no one's buying that, no one's selling that, except it's just Apple's, right? All the other 4K micro OLED displays, as of the recent past, they haven't been quite mass production ready, but they're about to be, or are, you know, without getting into confidential details, there's some 4K micro OLEDs. Everyone can go and see that and get that. And let's say even the yield issues are sorted out, and let's say maybe the next year they actually become readily available for real. There are still a lot of challenges. For example, and this is the hardest one, price. So this comes down to the fact that micro OLED displays are different from displays you might be used to, OLED displays like on a TV. That's a glass substrate versus micro OLED is based on a silicon substrate. So that means it's built using the semiconductor fab process. And wafers have a fixed cost. Well, it's not fixed, it's going up.
And you can't bin displays. You can't say, these bad ones will go in a separate headset.
Not really.
You only want the good ones.
No, there's a limit. So because of that, wafer cost, especially with I mean, the growth of NVIDIA and AMD and the entire AI wave from the past couple of years, followed by, I think, even the crypto wave before that and so on. The demand for GPUs and semiconductors have skyrocketed in the past few years.
That's so funny. Yeah.
Wafer cost is just going up and up and up, which means that when you have a wafer, if you have a 1-inch micro OLED display like what we have in Beyond 1 and 2, you are able to get a lot more displays out of a single 12-inch wafer. If you have a 1.3, 1.4 inch, you have a lot fewer displays, which means a single defect in one area, there's a greater probability of having worse yield issues. And your also utilization, you have rectangular displays or square rectangular displays.
They don't tile the same.
They don't tile the same way. It's just a lot of issues. And so because of the rising costs, 4K micro OLED is extremely expensive. So the price for one display is like more than a Quest 3 costs.
And I'm also hearing that, the difference between 1 and 1.4 inch, for example, that changed your whole form factor. Your parameters change for weight. And you got a lower weight even in 2. Where does that lower weight come from?
A lot of different things. So that's where everywhere that we can shave and optimize, we do. So it's materials work in everything that you see here. It's materials work in optics, in plastics. Even our electronics are as small as they can be. We'll talk about eye tracking in a bit, but even when we get eye tracking, the stiffeners that we use or the materials within it, the camera selection, how many LEDs to use. So everything has some level of impact on weight, and we've really focused on that as well.
Related to those last two things we're talking about, you guys have adjusted by BD, right? We'll show that in a little bit. How do you think about binocular overlap in relation to field of view?
Sure.
And also, DisplayPort 1.4, which is what you're using. I know it's a big thing that we talk about. It's what requires you to change the parameters between 75 versus 90 hertz.
Sure.
For example.
Where should we start? Let's talk about the DisplayPort 1.4. Unfortunately, most GPUs still only support 1.4. So yes, we can go to DP 2.0, which has much higher bandwidth capabilities, and there's a lot more we can do. But there's like a full stack of different changes there. We'd have to change how we're doing things at the driver level. We'd have to also change how we're doing things with electronics, all the way through to how things are done at the display. And some of the things on the display, they've been taped out quite a while ago to do a whole new architecture, to change some of the components that we have on, again, it's a silicon backplane, so there's a lot of actual circuitry on the display itself. That would be a significant undertaking that takes quite a lot of time. And everything has to mature kind of at the same time together. One single component dramatically maturing doesn't really help us solve the full stack.
I completely understand that. You're choosing the relative low-hanging fruit based on the resources you have.
And also picking, what are the areas that make the biggest impact. By really solving that, but not solving optics, well, it really doesn't make a difference. But once we've solved optics, what we're finding is, I have this design principle of peeling layers of the onion, right? We solve a couple of these. Well, now you're noticing new things that you didn't notice before, right? There were higher level things that were bothering people or that we could really improve. And now that we've improved that, well, there's more and more and more that we can always do. So let's talk about binocular overlap and the field of view. This is where things on a spec sheet just don't tell the full story. You can't just maximally optimize field of view. And what about the other components, right? Or maximally optimize edge-to-edge clarity and binocular overlap, but not the other aspects. Everything has to be kind of done in concert with each other, because ultimately, we're not buying this for the spec sheet. We're buying this for a great time in VR, right? And there's a lot that impacts immersion. Binocular overlap helps with a greater sense of depth and 3D cues. And you can go for 100% overlap if you need. And you can go really low, like sub 70%, sub 60%. Now you get really crazy field of view, but now you will have eye strain. It'll be dark in the middle of the view. It's just not quite right. So we find the right sweet spot, the right balance between the two. And a few devices have done this really well. So Beyond 1 had approximately a 77, 78% binocular stereo overlap. And this is just shy of that. It's like 77, maybe 76. So it's just shy, but in that ballpark. The Valve Index, approximately the same, around 77, 78 or so percent stereo overlap. Quest 3, they dipped a little low. In independent measurements, it's around, if I recall, 73% stereo overlap. That's probably the limit. Once you go below that, you can actually get some pretty significant eye strain and things don't feel quite right. But there is one thing that also can be adjusted to give you more stereo overlap. If you really want to get into the 80s, 85% stereo overlap, for example, just use a smaller IPD. Now that does require the optics to be really, really good, to have a great sweet spot, to have edge-to-edge clarity so that your eyes could actually be anywhere within the eye box to get a really sharp image. And that's now possible. So because we improved all these other parts about optics, we can also deliver a much higher stereo overlap for greater comfort, allowing you to pick between really maximal field of view, or
real good
just
depth.
bring it in a little bit more.
Comfort and,
But
and so you're saying that users can maybe use utility and say, my IPD might be, like 68, and I can narrow it, but in the software, say, still render it at for my IPD. But the actual hardware is a little tighter.
Exactly. So software IPD could be what you, want for correct scale. While you give yourself just a little bit, and this allows with our built-in IPD tool, or sorry, not built-in, with our included IPD tool, you can actually adjust it to get to the exact point independently for each eye. Some people have a little bit of asymmetry where one eye is a little bit shifted. And this allows you to fine-tune that exactly to the level that you need.
Are you going to have utilities or recommendations for people to run tests for themselves?
I think we will in the future. As of right now, there's a couple ways to do it. You can either use an iPhone or use a variety of different tools to get a rough sense of IPD. But frankly, our optics are so good right now. The headset comes at a 64 millimeter IPD out of the box before you adjust anything. 90% of people will probably never even adjust their IPD, and it'll be great right out of the box because the sweet spot's so big that even if your hardware IPD is a little bit off, it's probably going to work well for you. So once you get into VR, you can then make a few fine-tuned adjustments to get it to that right IPD for yourself. At some point, we do have eye tracking in the 2E version. There are things we can do there to help you get the right IPD.
Okay. I want to talk about that. So let's move over. This is your prototype for 2E.
It's not a prototype. So this is a pre-production unit.
Pre-production unit. This is shipping later this year.
We'll be shipping in 6 weeks, 8 weeks. Yeah. So it's actually coming up real fast. And
for clarity, like the face or the plates here, not technically. I mean, they're interchangeable, but they're not like the clear one isn't bound to the E, is it?
No, it's not. It's not. So we have 3 colors. We have carbon black, nuclear orange, and crystal clear. They're fully swappable. If people wish to, buy a faceplate and swap it themselves, they're more than welcome to. Be careful, but you can definitely do that yourself.
Okay. For our purposes, the E is this one, your pre-production unit. You have eye tracking now built in. I know your users had modified versions of Beyond 1 to put in things like eye tracking. Tell me about the implementation, both hardware and software.
This is a lot of fun. So we'll talk about hardware first. Our eye tracking implementation is, without doubt, the smallest eye tracking sensor suite of any VR headset ever made. If you look closely, that enclosure that you see right there, that's our eye tracking housing. The actual eye tracking sensor is the size of a grain of sand. If you look closely, you will see a white dot.
Oh, I see it, right there.
That white dot is the sensor. It's not the whole enclosure. And there's 2 infrared LEDs on each side as well. So it's 2 LEDs along with a tiny sensor. It's incredibly light. It's 1.05 grams for eye tracking. That is absurdly light. It's never been that light ever before. But the way we were able to achieve all of this and integrate it neatly into the entire headset and maintain the form factor, it's actually based off a lot of our software advancements. So our head of hardware and the co-creator of Bigscreen Beyond, Philip Krejov, his background's in computer vision. We have a computer vision team where we've spent a lot of time in the past 5 years working on cameras. I know we're a SteamVR-based headset. When we shipped Beyond 1, it had no cameras in it, but cameras are really, really interesting to play with and to get some really advanced functionality out of. Eye tracking being one of the biggest new features that we can really deliver with that. Latest advancements in computer vision and the AI wave has allowed us to train a state-of-the-art pupil model. So we really understand now the human eye, what it looks like, where it's looking, and what we can do with it. Gaze, emotion, etc.
With less data, you can get the same accuracy.
Exactly. So we're able to use really, really tiny image sensors now, where previously you might have had a much higher resolution, higher frame rate, because you had to. You can think of it as older ways of doing eye tracking were brute forcing it. You really had to see it, and computer vision was doing a heavy lift, typically very CPU intensive. This time around, we're also fine-tuning, training individualized pupil models, and then running it locally on your device to figure out where's your pupil, where are you looking? And we're able to do all this. It's kind of a nice tie between software and hardware. So our native software implementation allows us to really pull out a huge level of functionality out of something so tiny. You can have one without the other.
You get the same in terms of range of tracking. Does that also apply to prediction as well? So and
Potentially,
responsiveness? Yeah.
but as of right now, as of today, we've focused this on primarily the social VR use case.
Yeah.
So how do you use eye tracking to improve the look and feel of your avatar for expressiveness in social VR, to communicate body language cues, and to have a great time in VR? That's our first and foremost goal. The second goal after that, and this is a harder goal, is to get into performance enhancing features like foveated rendering. But now the bar that you need to hit when it comes to accuracy, precision, and latency is much higher to get to foveated rendering. And that's something we're working on. I do believe we'll get there, but I'm not going to promise it right now today, because that also requires a lot of software integration. Latency is not only in our camera, it's not only in our algorithms at the software level, it's also in the rest of the stack when it comes to rendering in VR, when it comes to the compositor, and then ultimately, how does it integrate with game developers' content themselves? We want to make that really seamless so that if and when we ever do ship performance improving features, that it just works. That, the Beyond 1 and Beyond 2, it's plug and play. If you've got an index, you plug in a Beyond and it just works. There's no weird software or things that you have to do. For eye tracking, we'd want the same thing. So we're not promising that, but I think we will get there. There's a level after that, and that's the Apple Vision Pro level, which is UI interaction. The amount of precision you need for that is very significant. I don't believe we're going to be focused on that for this.
Well, even just for performance, I think that tells you one to have a bigger panel and not require as much processing to get for playability, but also maybe to put this in an all-in-one package, right? And that's something that can run self-contained. So I guess that's my final question: is how do you think about this device being tethered to PC VR and Steam VR more specifically, and going forward, as we now know, people love watching movies on these things, on the couch, on airplanes. How can you put this in those environments?
Yeah, I think a lot of people have asked about standalone or how does this get to really mass market and so on. To me, I would happily just recommend the Quest. The Quest is an excellent standalone device. It's hard to compete also when it's subsidized and it's tens of millions of units, every year. We're focused on solving problems that other people aren't solving, to cater to a market that other people aren't paying attention to. So we have enterprise customers who they've bought the Vision Pro, they've bought the Meta Quest, and they're coming to us for very specific reasons. We're also catering to an enthusiast market that happens to care about the same stuff. Namely, that some of the customers that we work with, well, they end up using this for an hour, then they have to charge the device for an hour, and then they have to go back to the device. And it doesn't, that cycle time just doesn't meet the needs of certain companies who need it to be always ready to go. Our customers, our enthusiasts, they tend to use VR for a couple hours straight and they're just having a great time. So we'd love to stay focused on areas that we can make a really big difference in and really push those bounds. For example, optics that keep getting better, and electronics and displays, and all these interesting new capabilities that we can do with cameras and sensors in the future. Let's stay focused on that part, while I think Meta and others are going to chase the really big mass market. I think there are fantastic businesses to be built here. The best analogy for this, I think, is Meta and Apple. They're trying to make the next smartphone. However, I think at the same time, there's really interesting opportunities in laptops, desktops, workstations, and powered gaming consoles. The analogy there being that there might be VR devices of the future, like the Beyond family that you see here today, that allow for whole new different capabilities that are just in a different form factor. We don't necessarily need to make the same kind of standalone that other people do. But if there are things that we can do to make the experience easier, like some level of compute that you can carry around with you, perhaps off of your head, there are interesting things to explore in the coming years, but we need to explore them first. I think what I'm most excited about, we've just got a lot of exploration to do.
Yeah, awesome. Thank you so much. Great to have you back in the studio.
Thank you.
And congratulations on the launch.
Thanks, we're having a great time.
Thank you guys so much for watching that video. I would be remiss if I didn't tell you we have some excellent merch. We have a 5-pack of demerit badges for sale right now at tested/store.com. We've got the I hung it off of level demerit badge, the I built the chair backwards demerit badge, the I hit my thumb with a hammer demerit badge. We've got the stapler in my finger demerit badge, and my favorite, I stuck the duct tape to itself demerit badge. Get yours now, tested/store.store. Tested-store. Tested. It's right here. There. Just click there.